Have you ever been stuck in a coding interview where your solutions work perfectly, but then the interviewer asks you to optimize the space complexity to O of 1 without using any hash map? It's a common challenge, but today we are going to crack it. Hello everyone and welcome back to Techmine Guru. I am your coach Supratim. Today in lecture 18, we are diving into finding unique elements and sub-array logic by tackling some of the best bit manipulation interview problems. We have three exciting challenges on our agenda today. First, the thrice recurring array, where we will find the unique number in an array where all other elements are occurring 3 times. Second, the sub-array OR puzzle, where we will count sub-arrays where the OR operation equals 0. And third, the inverted twist, where we will count sub-arrays where the OR operation equal 1. So let's jump onto the problem 1, the unique element. So you have been given an integer array where all elements occur twice except 1. Find that unique element. So if you see this array 4, 5, 5, 4, 0, 6, 6, 4, 5, 6, you will see 4 occurred 3 times, right? Similarly, 5 has occurred 3 times, and similarly 6 also occurred 3 times, but 1 has occurred 1 time only. So how we will solve this problem? So if we try to solve this via using nested loops, where we will count the frequency of each element, the time complexity will be O of n square. So we don't want this solution. Similarly, if we calculate it via Hashmap, where we will store the frequency of each element by counting how many times they occurred, that will be O of n only. But that time, since we are taking extra hash map, so which will give us space complexity as O of n. So let's see how we can solve this using bitwise logic, and this will give us O of 1 space solution as well. So what is the intuition behind it? So the intuition is we have to think in bits. So suppose we have been given an array 5, 5, 5, and 4, right? So let's think we are writing the binary representation of that number. So 5 will be represented as 101. This 5 will be same, this 5 same 101, and this 4 100. So if we see this pattern column wise, we will see if a number appears 3 times, its bit sum to a multiple of 3 at any position. So since 5 has occurred 3 times, so in this 0th bit position, how many times the number 1 came? 3 times, right? Similarly, in this, how many times number 1 came? Since all of them are 0, so this will be 0 only. And similarly, if you see for this 3, 5, how many times this number 1 came in the second bit position? It will be 3 times. But since we want to find the unique element, which is 4, it is also contributing 1 bit in the second position. So the number of bits here will be 4. So what you understood from this, that if the number has occurred 3 times, it will contribute 3 set bits on that given position. So let's see the code for this. So we ran a loop for int I is equal to 0 to 32, because int range is 32 only. So since we are thinking it column wise, we will run a loop on each bit, right? Like this, we will run a loop along each bit. Now we are iterating into the array, which was suppose 5, 5, 5, and 4, and we are checking whether the bit is set or not. So for checking the bit is set or not, you remember from our last class, we used x and 1 left shift I, which will tell whether that position bit is set or not. So if we see for this example, on the 0th position for the first number, we will see this 0th position bit is set to 1. So our count will increase to 1 here. Similarly, when we will see for this 5, we will again see in the 0th position, the bit is set to 1. Similarly, in the 0th position, for the third element 5, we will see that this bit is set to 1. Now the count will become 2, and then finally the count will become 3. Once the array elements is over, we will come to this block. And lastly, for the fourth element, which is 4, we will see that bit is not contributing anything, right? How many set bits are present in this 0th position? 3, right? Now we will come out of this loop and we will see if count mod 3 is not equal to 0. So we have taken the answer variable as 0. And since count is already 3, this if will not work for the 0th position. So answer will be 0 only. Now we will move to the second bit, which is at the position 1. So we will check whether the bit is set or not. So for all these elements, we will see that we will not get any set bit. So the count will remain 0 here. For the second position, the count will be 0 here. So again, 0 mod 3 will not be equal to 0. So the answer will stay 0 only. Now we will move to the second position when I is equal to 2. We will check whether in second position, how many set bits are present. So for all these 3 elements, we will see that 1 set bit is there. Count will be 3. Now for the last element 4, we will again see that this bit is also set to 1. Now our count will be 4, right? Because number of set bits present in second position will be 4, right? So now we will come to this condition. We will see 4 modulus 3 will not be equal to 0. We will set the bit. How we set the bit? We learned this from our previous classes. We will do answer or 1 left shift I. So what is the I now? I is 2. So our answer will be 1 0 0. So this will only give us that unique element which is present in this thrice occurring array, right? So this is a Leetcode problem. The link I have mentioned in the description as well. So what is the time complexity here? So if you see, there are 2 for loops, right? One which is running from for I is equal to 0 to I is less than equal to 32, and another which is running over the array. So this is O of n, and since this one is running from 0 to 31 iterations only, so this will be O of 32n, which is again approximately O of n only. And since we are not taking any extra space, the space complexity is O of 1 only. So let's move on to the second problem of our day, which is doing subarray or with 0. So you have been given an array of zeros and ones. You have to calculate the number of subarrays where the bitwise OR of all elements is 0. So suppose the number is 1001. So how we will do this? So let's see the observation behind this. Since we already know the bitwise OR is 0 if and only if every single element in the subarray is 0. So if we remember that we get 0 only when we will XOR it with the 0. Rest all other times we will get the answer as 1. So in this we will simply look for consecutive sequence of zeros in the array. And how we will count the number of zeros? So suppose there are 3 sub-zeros. We already know that if we have a length of array with 3 elements, we will get how many subarrays? It will be 6, which will be count into count plus 1 by 2. So if we have a length of subarray with 3 zeros, then the calculation would be 3 into 4 by 2, which will give the answer as 6. So suppose let's take an example and let's see the code. So we have 1 0 0 0 1 0 0 1 0 0 0 0 0 0 like this. So we have to count the number of subarrays. So in this we have to keep an intuition that every time we encounter a 1, we will reset the count of number of zeros as 0. Why? Because every time this 1 will drop the previous occurring zeros. So if we see in this block, we have 3 zeros, right? So how many subarrays of zeros will be possible? It will be 6, right? 3 into 4 by 2. Similarly, if we see this also as 1, then here 2 zeros are present. So it will be 2 into 3 by 2, which will be 3 subarrays with 0. Similarly, at the last, we have around 6 zeros. So it will be 6 into 7 by 2, right? So which will give the answer as 21. So how many subarrays are possible with these zeros? 21. So what is the total number of subarrays which we are getting with OR 0? 6 plus 3 plus 21, which will be 30, right? So let's see the code. So in the code, we have taken a count is equal to 0 and the final answer, which will tell us the number of subarrays where the subarray OR will be 0, right? So for that, we ran a loop for int I is equal to 0 till n, and whenever we are encountering a 0, we will increase the count, and whenever we will encounter a 1, we will simply stop it, because whenever we encounter a 1, we will see whatever zeros are present before that 1, like that. So here we are calculating in the answer plus count into count plus 1 by 2, and at last we are resetting the count as 0, so that when we will again move to the next part of the array where we will encounter 0, that time again we can count the number of subarrays with these zeros. So now again a of I will come as 0, our count will become 1 when we are here, then we will move to there, the count will be 2, right? Now again we encountered a 1 here, so again we will stop here, we will see the count as 2, so we will do 2 into 3 by 2, which will come as 3. Again we will reset the count, and similarly we will keep counting till the end. So why we have added this extra answer count? Suppose if after the last one we have got all the zeros, that means those will be considered as a trailing 0, and those count will be already calculated by this. But again, at the last for the trailing 0, we need to have the subarray count of those zeros. So this 21 will be getting from this. So 6 plus 3 plus 21 will give the final result as 30. So what is the time complexity here? Since in this code we are running one for loop only, that is from I is equal to 0 to n. That means the time complexity is O of n. And since we are not taking any extra space, the space complexity is O of 1 only. Now let's see the last part of our problem, which is to calculate the number of subarrays where bitwise OR is 1. So till now, we already know if we have given an array of zeros or ones, we know how to calculate total number of subarrays. It will come through the formula of n into n plus 1 by 2, right? So if you see the total subarrays, what it will be? So it will be subarrays where OR is 0 as well as subarrays where OR is 1, right? So if we simply interchange the formula in this, then we can easily get the number of subarrays where bitwise OR is 1. So our answer will be the total number of subarrays from the length of the subarray and the subarrays which we have already found in our previous problem. So by just applying this formula, we will get our solution. So here we have number of subarrays with count 0, right? We will simply subtract that from the total number of subarrays. Total number of subarrays we will get by this formula, where n will be the length of the array, and this we have already calculated. We will subtract both of that and we will get our desired result. So this is also a Leetcode problem. The link I have mentioned in the description as well. So this is also like an extension of the previous code only. So the time complexity will remain the same, which is O of n, and the space complexity is O of 1. Since in the previous code also we have seen we have not taken any extra space. So the time complexity is O of n and the space complexity is O of 1. So today we have mastered 3 powerful bitwise patterns, the mod 3 rule for finding the unique element in an array which has every element occurring thrice. Then we found the zero island problem, where we calculate the number of subarrays whose bitwise OR is 0 by counting the individual subarray zeros. And finally, we use this inversion trick to get the number of subarrays whose bitwise OR is 1. So just remember guys, complex problems often have simple visual patterns. In the next lecture, we will learn about some basics on recursions. So if this breakdown help you see bit manipulation clearly, hit that like button and subscribe to Techmine Guru. With this, signing off for today. Till then, keep coding, keep optimizing, and keep learning.